This is the case of d-transposition of great arteries. You will find how to diagnose d-transposition of great arteries. In this image, you see apical four-chamber view, RA and RV. This is LA and LV. RA, RV more in size compared to LA and LV. So dilated RA and RV. Second thing, in this image you see possibility of ASD here. This is next image. It shows how you can see the ASD. ASD is there. You can. This is left atrium. This is right atrium, and that is ASD. This is the superior vena cava. This is right pulmonary artery. So mainly you see this is right atrium and left atrium, and then ASD. The next image shows you flow through ASD. Flow is red in color, so flow from left atrium to right atrium, left to right flow. So you see this SVC flow, this is right atrium, this is left atrium, and flow through ASD. This is the image you see. This is right ventricle, this is aorta, this is left ventricle, and then pulmonary artery. There is little flow obstruction in pulmonary artery as you find more turbulence in pulmonary artery. You can clearly see right ventricle to aorta and left ventricle to pulmonary artery, that is ventriculo-arterial discordance. So VA discordance. RV to pulmonary artery, RV to aorta, and LV to pulmonary artery. Again, the 2D image you can easily see is right ventricle to aorta and left ventricle to pulmonary artery, and there is VSD also. VSD is mainly subpulmonary in location. Follow through VSD from right ventricle into pulmonary artery, that is from right ventricle into left ventricle and then pulmonary artery. This is next image. You can see both aorta and pulmonary artery in short axis, and both are seen in one view. If whenever you see in one view both aorta and pulmonary artery in same plane, I mean it means both in short axis, you can see both valves in the same view. That means the case of transposition. You can see there the PDA with bidirectional flow. Flow is mainly left to right, that means from aorta to pulmonary artery, but it reverses also, so that is bidirectional flow. Whenever left ventricle gives rise to pulmonary artery, as the pulmonary artery moves forward, it goes downwards. So this is left ventricle, this is pulmonary artery, and it goes downwards. A structure arises from left ventricle. If it goes downwards, that is pulmonary artery. If it goes upwards, then it is aorta. So in case of d-transposition, a structure that arises from left ventricle should go downward. That means it is pulmonary artery. I am trying to show the same thing again. How pulmonary artery, aorta arises, pulmonary artery arises from left ventricle and goes downwards. In short axis view, you can see that D-shaped left ventricle chamber suggestive of raised pressure on right ventricle side. That is, our right ventricle systolic pressure is raised in this condition. That is a total the case of d-transposition great arteries. Just revising: D-shaped pulmonary artery rising from left ventricle going downwards. Same thing. PDA with bidirectional flow. Both pulmonary artery and aorta at the same level. You can see both in longitudinal direction, long axis is in the same plane. ASD, the fourth chamber view.